In this example, we're going to use a binomial probability distribution to determine the probability that a certain number of flights are on time, given this information here in the problem. If you haven't already, pause the video to read the full problem statement. What I'm going to focus on here in this particular video is more about how to find these probabilities using the TI-84 calculator. So I'm going to go ahead and assume that you can select Y. This is a binomial experiment, and that you can also determine the values of N and P appropriately. So we're going to jump down to the probability that exactly 8 flights are on time. Well, if we've already identified that this is binomial, then we're using binomial distributions. And in the calculator, we will find those underneath second vars, which if you'll see here in blue, it says for short, that's distribution. The binomial distributions are towards the bottom of the list. One way to kind of get there that I just prefer is to actually press the up arrow to get to the bottom of the list. And because this is the word or phrase exactly 8 flights out of 13 are on time, I'm going to use binomcdf. Okay, so I'll type in here that we have 13 trials. We already stated that the probability of success was 0.8. And the particular X value that we're looking for here is 8 flights. Okay, so exactly 8 flights on time. Now, when I click enter on paste, notice that it puts all those parameters in the calculator for me. So if you're running off of an older calculator, you would type in these numbers in this order with the commas between. When you press enter, now you have that probability. For this next part, you would just multiply that by 100 to get the expected value out of 100 flights. So I'm going to jump down to part D. This part's a little bit different because we're asked what's the probability that fewer than 8 flights are on time. So that would be 7 flights, 6 flights, 5 flights, so forth and so on, all the way down to 0 flights being on time. Those are all the binomial PDFs we would have to determine and then add those together. Well, because there's so many of them, there's a better distribution that we could use here on our calculator, and that's the binomial CDF, the cumulative density function. So I'm going to select that one. I still have 13 trials. I still have a probability of success of 0.8. But this time I'm looking for fewer than 8 flights being on time. And the way the calculator, right here, fewer than 8 flights being on time. The way the calculator and the binomial CDF function interprets that is 7 or less. So for my X value here, I'm going to have to do 7. And that's how I get this probability of 0.03. Part E is kind of the flip side of that. Well, then if this is the probability that fewer than 8 flights are on time, the probability that at least 8 flights are on time would be the probability that 8, exactly 9, exactly 10, 11, 12, and 13 are on time. So that's everything that this is not. And in that case, we can use the probability of at least formula, where we take 1 minus that previous answer, and when we can get that probability fairly quickly that way. The calculator does not do that greater than type statement that you see here in part E. So even if you were asked about something like this in part E of 8 or more flights, then you would first technically go through and do this one, and then do 1 minus that answer to get everything to the right. And then the last part, part F, find and interpret the probability between 6 and 8 flights. You have some choices. You could do a binomial PDF of 6, 7, and 8 flights exactly and add those together. Or you could do 2 binomial CDFs of 8 and less, and then 5 and less, and subtract the 2 choices, or those 2 answers. So I'm going to show you binomial PDF, first of all. So that's choice A. We're doing here 13, same probability. We have 6. Okay, so that's exactly 6. I can copy this by doing second enter and change this now to exactly 7, and copy that again and change this now to exactly 8. And then I can add up these 3 probabilities. Actually, I probably could have added those together all in one line. I'm going to do this plus this one plus this one. And then I have the probability that exactly between 6 and 8 flights, inclusive there, are on time. That was one method. And that's not too long to do. So I would not, I would say binomial PDF is appropriate. But if you had a little bit larger window there, you may want to use binomial CDF. So to do that, we're going to take binomial CDF. We want to get the probability that 8 or fewer flights are on time by doing this one. And then we're going to subtract the probability, another CDF function, that 5 or fewer flights are on time. If we subtract 5 or fewer, then we're still including the 6. Notice how I can put that all in one line. That's what I was trying to reference earlier with the binomial PDF. And I get the same probability. So you do have some choices there with part F.